Yeah, thank you, and good afternoon. I'm Paul Schwarzenbeger, and 10 steps to Lambda security. So first of all, a little bit about myself. I'm a cloud security and DevSecOps specialist, so I help organizations move key workloads and applications to the cloud. And I speak at various security conferences, such as DevSecCon and Security B-Sides. I'm also a trainer delivering both classroom training with 44Con, and I've just launched my first security course on A Cloud Guru on Azure security. So I'd like to start by talking about the Capital One data breach, which happened in May this year. And this isn't serverless, but you'll see where I'm going later on. So this lady, Paige Thompson, hacked into Capital One and got data with 100 million bank account and credit card applications. And she also obtained with that 140,000 US social security numbers and 1 million Canadian social insurance numbers. Now, before I go on further, just want to say that Capital One have some really good security people. They're one of the leaders in cloud security, and yet still this happened to them. So it really could happen to any organization quite easily. The likely fine is expected to be between 100 and 500 million US dollars as a result of this breach. Capital One did find out about the breach pretty quickly. They identified that the breach had happened in June, which is only a month after the loss, and that was due to the fact they'd actually put in place a responsible disclosure program. So how did that actually happen? So Capital One had a virtual machine in AWS, and it needed to access an Amazon S3 bucket, and that's a very usual sort of thing that happens a lot. It might be that it was backing up to S3 or reading some data off of S3. That's very common. And to allow the virtual machine to do that, the way that that's done is through AWS Identity and Access Management, or IAM. And within Identity and Access Management, you can set up policies that give certain permissions to do certain things, and then associate those policies to a role, and then you can assign the role, in this case, to the virtual machine. The virtual machine can then access the AWS metadata service, which is actually effectively on the virtual machine itself, so that's like a local address within the virtual machine, and that information is passed to the virtual machine by Amazon. And within there, there's a whole load of useful information for the virtual machine, including the session tokens to allow the virtual machine to assume that role and then get those permissions. So the virtual machine goes to that URL, gets the temporary keys and session tokens, or session token, and then uses that key, or the keys and session token, to access S3. So that's all great. And then what the attacker did, in this case, Paige Thompson, she accessed the virtual machine, accessed the machine via web interface, and then because the configuration of the virtual machine, the application on the virtual machine was misconfigured, she exploited a server-side request forgery, SSRF, which meant that she could then actually get that information by browsing and intercepting her web calls to access that information. So she then got the keys and the session token, and then she could then directly connect and retrieve the data from S3. So that's what she did. She had previously worked for AWS a few years ago, So she had a good understanding of AWS technology and systems and the fact you could do all of this stuff. However, she certainly wasn't an insider. So that's Capital One data breach and how it happened. So the question is, could this or something very similar happen with serverless? So to try and determine this and test this, I created a very simple Lambda function, and I called it bad Lambda. It's on GitHub, github.com, Celidor, bad Lambda. And all this Lambda function does is print out the environment variables of the container in which the Lambda function is running. So now we'll try and do a live demo and see if it all works. OK, so I've set up a Lambda function. And you can see from the console that the Lambda function has some rights to access AWS Secrets Manager and also Amazon CloudWatch logs. And that's really quite a normal sort of thing, because it might be that there's some parameters or passwords or whatever in Secrets Manager that the Lambda function needs to get hold of. So you would expect it to have the permissions like that. And it needs access to CloudWatch logs to write the actual logs. Scrolling down, you can see the code. This is my amazing Python code. I'm hoping you're all going to be impressed with that, to print out the environment variables. So if I go to the API gateway, the API gateway is what exposes the Lambda function to the internet. So I'm going to click on the link to open up a new tab. And as expected, this returns the Lambda function. The Lambda function returns the environment variables of the Amazon Linux container on which the Python code is running. So you can see if you sort of look down that list, or maybe not, because there's a lot of text there, but you can probably see that there's a session token at the top, which is the same as the security token here. And there's also a AWS secret access key and the AWS access key. So they're the three things that are needed. So I've got all this information. So what I then did, and this bit I didn't want to do live because you'll just get bored of me typing. So what I then did was to edit the credentials file within my AWS CLI, command line interface. So if I go to .aws and then look at cat credentials. So this is my AWS access key, secret access key, and session token, which I've just grabbed from the output of that Lambda function. And hopefully the session is only for a certain duration, so hopefully that hasn't expired since I edited it to do this for this demo. So I've now got the session token on my laptop. So now I can do commands such as AWS Secrets Manager list secrets. So this should list all the secrets within Secrets Manager, and it does that. And then I can choose one of those secrets. And then actually get the details of the secret, including the actual value of the secret, which is that secret string down the bottom. So that's a sort of illustration of how, if I had compromised that Lambda function in such a way that I could print out the environment variables, I could grab all of that information, and then I could do anything that that Lambda function is allowed to do. So moving back to the PowerPoint. I'd suggest that there could well be a serverless data breach next year where AWS Lambda needs to access Amazon S3 and does that by having a policy and a role assigned using AWS Identity Access Management. The Lambda function gets the container environment variables to do this, including the key, access key, secret access key, and security token, and then uses that information to access the data in S3. An attacker can then, via the API gateway, if it's a Lambda function exposed to the internet, could potentially exploit a command injection vulnerability within the serverless function to get hold of those environment variables and then directly get the information out of S3. And before you know it, there's another $50, $100, $500 million fine. So to combat and help mitigate this sort of risk, as well as some of the other risks of running serverless functions, last year I developed 10 steps to Lambda security as a practical sort of guide of things, like a checklist of things to do, a good practice from a security perspective with AWS Lambda. The list is here. I'm not expecting you to read that, so I'll go through it one at a time. It is also on my blog, www.celidor.co.uk. So let's just go through them one at a time. So the first is and these are sort of in order of importance, but not necessarily. But the first is to use environment variables for configuration details and encrypt with KMS. So when you start a serverless function, when you create a serverless function, then there's a whole load of configuration details that are needed. Some of those are going to be sensitive. So just to illustrate that, if I have a look at, I've got some other Lambda functions which are used for continuous compliance. So if I have a look at one of these, this is, for example, a Slack one to send a Slack message. And one of the things that's somewhat sensitive is the Slack webhook URL, because if that became public, anybody could post anything they wanted to the Slack channel. So, so those are all listed as environment variables. And if you look at the encryption configuration, you can see that those are all encrypted with a key in Amazon KMS, Key Management Service. Now you might think, and probably quite a few of you maybe think, well, isn't that perfectly obvious? But at least at one of the organizations I've worked with, I had when I was doing a sort of security audit, I had a look at the code of a Lambda function that somebody had created, and actually right at the top of the Lambda function, within the code, somebody had put in an AWS access key and AWS secret access key. So it's unfortunately not obvious to all people that you should do this. But you definitely should, because if you do put information directly into the code, then it can be compromised in the source code repository, and also anybody who has read-only access to, for example, the AWS account can escalate their privileges and do whatever that particular identity is allowed to do. So yeah, so that's the first one. Moving on, moving back to the PowerPoint. The second one is to retrieve sensitive data from DynamoDB, Secrets Manager, or similar service. So whereas configuration details and confidential information such as maybe passwords or keys and certificates can potentially be implemented as environment variables through Lambda, where there's application data that's sensitive, that should be held off of the Lambda function in a database or similar sort of service, and then secured appropriately there. Number 3 is enable encryption helpers to protect data in transit. So the containers running Lambda are on virtual machines, and they get hold of the environment variables. That passes over a network that's shared with other traffic. So it's good practice to encrypt that data. You'll actually see that I haven't been very diligent in that respect. So what I should actually do here, so in this case I haven't enabled that, so what I should do is tick that box and then choose a key here to encrypt the environment variables in transit from where they're stored onto the actual server that's running the Amazon Linux containers. Going back to the next one. So configure API gateway custom domain with SSL cert for web access. So again, I haven't done this myself on this function. So on this function, you'll see that the URL for that is just the Amazon URL. What I could have done is map that to a custom URL. I mean, if it's being called from an application, it may not be so important, but if it's actually the end user directly going to the Lambda function, then if it's just going to the Amazon generated domain name like this, it would be very easy to trick somebody in going to a malicious or different Lambda function from the one they should be going to. So the API gateway can be set up with a custom domain name and SSL certificate issued by AWS Certificate Manager, and that's good practice, particularly when an end user is directly going to a Lambda function. Then moving on. So this really relates to the demonstration I gave earlier, and this is minimizing using the security principle of least privilege, listing the minimum specific actions in policies, and also, as far as possible, restricting the resources that that policy applies to, and again, where possible, putting conditional statements in as well, so that if anybody did steal the keys, as I just demonstrated, then what they could do with those keys is limited. So try not to use star, which nearly everybody does to start off with when they're testing something, and then, in my experience anyway, what tends to happen is then it just gets pushed out, and then nobody bothers to go back and list the specific permissions later. So when I'm developing this sort of thing, what I usually do is to actually start off with nothing and then just put in the specific permissions until the whole thing actually works. So that's sort of recommended. The servers on which, and the infrastructure on which Lambda is running has unrestricted access to the internet. So this is really potentially quite a major risk because, and quite a significant risk, because if a Lambda function is accessing or potentially manipulating sensitive data, if anybody can compromise the code of that function and put in their own module, that module could potentially copy data and just take it off to some third-party server under the attacker's control, and you'd never even know that was happening because that traffic wouldn't be logged in as part of your account. That would just be going straight from the Lambda service to the internet. So, so that is an important consideration, and it's not that easy to do, but there are some organizations who have written modules that you can include within your code that can enforce this. So it may be worth taking a look at some of those if you haven't already. Don't use /temp for sensitive information. So it has been shown that the /temp directory, which can be used for manipulation and storing large amounts of data that are being processed, that does actually persist from one invocation of a Lambda function to the next. So what that means is that if you put anything sensitive into /temp, then the next person who comes along and uses that Lambda function could actually access somebody else's data. So that's an important consideration as well. And as with any other system running applications, it's really important to do thorough application security testing and source code analysis to make sure that there aren't, for example, the remote code execution vulnerabilities which might lead to being able to an attacker to get hold of the environment variables of the Lambda function. And easier said than done, ensure that there are no vulnerable or unmaintained dependencies. So I mean, I've created some Lambda functions and then had a look at them afterwards and seen that there's about 30 or 40 different dependencies. It's really quite a challenge to determine if they're all up to date and if they're being properly maintained. Again, there are third-party organizations and vendors who have some solutions to address this sort of issue. So again, maybe worth looking at that. But this is a challenge firstly to check in the first place and then to keep track of vulnerabilities over time. And the last one is to monitor Lambda logs and investigate unusual behavior. So all of the what helps with that, I suppose, is making sure that the Lambda function is written in such a way that it does actually log useful information as well. So if you go to monitoring, a few logs in CloudWatch, you'll see, for example, the logs of this particular function, which sends a Slack message. And this is probably an example of not particularly interesting and well-written logs because there's not much information there. But ideally, you would log some useful information as well. So that concludes the run-through of the 10 steps, just listed again for reference. And again, they are on my blog if you want to refer to them. So with that, I'm going to finish. Nice and short. You have a little break before the next talk. Thank you.